Okay, so how many of these shapes do you know? What do you call a shape with three sides?
Triangle.
Triangle. Any questions?
No.
What about a shape with four sides?
Square.
No.
Rectangle.
Quadrilateral.
Quadrilateral. In geometry, a shape with four sides is known as a quadrilateral. Once you get past 3 and 4, they go to their more contemporary geometric names. A shape with 5 sides. Pentagon. Because penta means 5 and gon means sides. 6 sides? Hexagon. 7 sides? So it could be a heptagon or septagon. So hepta or septa is what we call 7. A little bit of flavor there for you. 8 sides.
Octagon.
Octagon. 9 sides. Nonagon. Nona. Gon. 10 sides. Decagon. 11 sides. So, you're absolutely correct. But, this is a pretty big classroom that is unacceptable. Oh. So say it one more time for me. What'd you say?
11
No, that's even further off.
11 gone.
So 11 gon would be better. 11 agon. The agon part doesn't mean anything. It's just GOA. 11 gon would be correct, but in a pre-P class, you need to know it's an decagon.
That's
It's basically
decagon.
1, 10.
That's like saying un is 1, like uno. Deca is 10, like
I know the
decade.
next one.
And gon is sides.
I said
1, 10 sides. 11 agon. And then 12.
Dose dick.
Dodecagon. Dodecagon. So, dodecagon. Alright, so y'all should know 10, like decade.
1 and 2.
Yeah, so that was, we all skipped over 1 and 2. What do you call a geometric figure with one side?
A line.
A line.
Bam. Good guys.
What? Yes, a geometric figure with 2 sides is called an angle. So I need you guys in pre-P geometry to know 3 through 12. So it goes triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, and then everyone in geometry is expected to know how to name a shape with 47 sides.
47.
47.
Quad.
47 gone.
Wow.
So look, don't tell YouTube, for the past 10 years, I've been putting 47 agon. But it's just 47 gone because hepta, septa, hexa, deca, they all have the A contained in there. And then gon means sides. So hexa is 6, gon is sides, 6 sides. So this is a 47 gon. That's a 47 sided 47.
So 47 gone is the right one.
Yeah, 47 gone. That's 47 sides. But so after 12, you can stop and you can say 13 gone, 14 gone, 15 gone, 16 gone. It is technically correct to say 6 gone. But as a pre-P kid, you know it's hexagon.
Another name for 47.
There is, so you can use the Latin stuff. Like it would be, for 13, would be like a tridecagon, it's like quadridecagon, then pentadecagon, and then hexadecagon. Like, and then you get to 20 and they get really weird. It's like unventagon, and like doventagon. It's really, I don't know. Yes, sir.
What's the number for number 7? What's the name for
Number
number 7?
7 is heptagon or septagon. Either way. So that's kind of the general naming that we're going to do. Now, the whole purpose of this lesson is to determine how many degrees are inside of any given polygon. Alright, so let's start with a really, really complicated one. Our goal here is to figure out how many degrees are inside of any shape. How many degrees are inside of that polygon?
180.
What shape is it?
It's a triangle.
Triangle. How many degrees are in?
180.
And why?
Because that's a triangle.
Yeah, that's the we did the triangle interior angle sum theorem. Says every triangle has how many degrees in it? 180. Tough stuff. Right, now let's try this next shape. What is that?
Quadrilateral.
It's a quadrilateral. And it's our job to figure out how many degrees are inside of this quadrilateral. How do you know that?
It has two triangles.
Whoa.
Well, if you cut it,
How do I say it?
if you cut it in half like that, there's two triangles, one on each side.
So I'm going to fix that. If you draw a diagonal from one vertex to the other. Now, this is a really easy concept, but you guys get very creative when you do this. Once you pick a vertex and you draw a diagonal from the other vertex, it creates two triangles. So there is two triangles there. How many degrees are in each triangle?
So 300, 180.
180. So 2 times 180 is?
360.
So inside of every quadrilateral, how many degrees are there?
360.
360. All right, what do you call this?
Pentagon.
It's a pentagon. You're saying that it has 5 sides.
I didn't have.
Then how many degrees are inside of this pentagon?
360 plus 180. Yeah, that many.
There are 3 triangles inside of every pentagon. And what's 3 times 180?
5.
540 degrees. Guys, this is straight up skateboard math. Right? 180, 360, 540. So inside of every pentagon, there is 540 degrees. How many degrees or what do you call this shape and how many degrees are inside of it?
Hexagon. And then what's
Oh, it's a heptagon or
You fell for the trap, didn't you?
Dang it.
You were looking for patterns in math class and you failed miserably. How many sides does this shape have?
7.
This has 7 sides. 1, 2, 3, 4, 5, 6, 7. So how many triangles can I draw inside of that 7-sided figure?
Why did you?
5.
4.
It just goes up.
5, right?
How many 180s do you see?
5.
5. So what's 5 times 180? 900. Let's go back and explore something real quick. How many triangles are inside of that 7-sided figure? 5.
Oh, it's always 2 less.
How many triangles are inside of that 5-sided figure? 3. How many triangles are inside of that 4-sided figure? 2. How many triangles are inside that 3-sided figure? 1. Isn't that kind of weird, though? It's always 2 less triangles than the number of sides that it is. So if it has 7 sides, how many triangles are there? 5. So we have this formula. Write this down, please, somewhere. The interior angle sum theorem for any polygon is n minus 2 times 180. Let's talk about the formula. What do you think n represents?
The number of sides.
The number of sides that given figure has. So how many sides does this figure have? 6. Which means it is a hexagon. So if I want to calculate the interior angle sum, it's 6 minus 2 times 180. The next step would be PEMDAS parentheses first, 4 times 180. And 4 times 180 is 720 degrees. So inside of every hexagon, there's 720 degrees. This is the main meat right here, your new formula, instead of drawing diagonals every time. So you don't necessarily need a picture or diagram to calculate the interior angle sum of a figure. How you feel right now?
Pretty good.
Awake?
Yes.
Love and life?
Yes.
Did you miss me?
No.
Cool. So, what is the difference between a regular polygon and a polygon? You should know.
They're both polygons.
Correct.
Regular polygons don't have inverted sides.
I see where you're going with that, but you didn't say it right. No, you're thinking about convex, concave. No, that's not. So convex and concave polygons are irregular polygons. What makes it regular? Let's do an experiment. Okay, what is this? What is this? It's a quadrilateral. What is this? It's a quadrilateral. This is a regular polygon. So what makes this a regular polygon versus this?
All the sides are the same.
It has two parts. All sides are congruent and all angles are congruent. So a regular polygon has all equal sides and all equal angles. So for this quadrilateral, over here, the blue one, how many degrees are inside of this quadrilateral? Degrees. 360 degrees. And you can calculate that by doing n minus 2 times 180, where n is 4, because it has 4 sides. So for the green figure, the regular quadrilateral, how many degrees are inside of that shape? 360 degrees. So what is the purpose of a regular quadrilateral? What is something, is there any way for you to tell me how big that angle is? It's impossible. But can you tell me how big this one is?
Yes.
How did you get 90?
Because it's all of them.
Correct. If you take the interior angle sum and you divide it by the number of congruent angles that it has, it will return you a number of 90 degrees.
Is that why you didn't mark them as right angles?
Correct. Because I did not know they were right angles until I proved that they were right angles.
Why'd you ask?
Yes. But we're not going to do paragraph proofs or like 2-column proofs. We're going to do puzzle proofs in here. I'm going to give you Legos and tell you to prove things. I know, look at you, you're so excited. So, here's our last formula here. Well, you know what? Let's try it again. What do you call that?
Pentagon.
This is a pentagon. What do you call this?
Pentagon.
It's a regular pentagon. You see the difference?
Yes.
All equal sides, all equal angles. So how many degrees are in any pentagon?
540.
5 minus 2 times 180. 3 times 180, 540. So there's 540 degrees in this pentagon. How many degrees are in this one?
540.
So if I ask you to identify the measure of one interior angle of a regular pentagon,
180.
how did you get that?
I divided by 40 by 5.
So inside of any regular pentagon, each individual angle is 108 degrees. So the last formula I'm going to give you guys today, it's like right now, the measure of one interior angle for a regular polygon is n minus 2 times 180 divided by n. That's what we have been doing. You take a 5-sided figure and you divide it into 5 equal pieces. So it's a combination of the last formula and this one. That only works for regular polygons. So if I gave you a 100 gon, and ask you to calculate how many degrees one individual angle was inside that 100 gon.
Oh, shoot, it's not.
Something like that, right?
176.4.
176.4. How did you type that in? Like we had this
I
problem in
did,
the last class.
I did 98 times 180, and then I got 17,
Can I make a recommendation?
17,640.
Can I make a recommendation?
Yeah.
So when you do this, just type in what you're trying to compute. 100 minus 2 times 180 divided by 100. That's what you're trying to compute. That way you know that these two numbers match. It has 100 sides dividing it by 100 sides. Put a decimal there just in case it comes back as an ASCII number. 176.4. It means that each angle in a 100-agon is 176.4. Well, what do you think about for like, I don't know, a 500-agon? It's going to be like 181 maybe? 182? Can we try it? Sure.
It's 179.28.
179?
There's no way because that's a
What if I did like a 1,000-agon? That should definitely be over 180, right?
It's 179.64.
What?
How does that
Maybe
even?
just be
How
What
does
about a 5,000-agon?
How
Man.
about
It won't get to 180 because then it's just a line. I know your tricks.
I'm proud of you. Oh,
That's so frustrating,
That's
man.
the first time I've ever heard that.
proud of you, son. Oh, what did I forget to do?
You forgot to add the
Decimal.
decimal. No, just
Control Enter.
no, just press times 0.1.
179.928. So no matter how many sides, that shape has 5,000 sides. And it has 5,179.928 degree angles that are all exactly the same size.
Wouldn't that just look like a circle?
It would exactly look like a circle. So
But
we
it's
beat
not
you.
a
I'm
circle.
proud of you.
almost a circle?
Almost a circle. So when you get shapes that are infinitely, you zoom out on them, it looks like a big circle. So that's when you finally break the rules of geometry and you enter the world of circles, and all the properties are
Are
different.
we ever gonna go over circles?
Yeah, that's the next thing.
Oh god.
But we have to finish quadrilaterals and then trig.
Do trigonometry?
Yeah, we're gonna do trigonometry.
Go right
Okay,
there.
so we kind of covered this already, what an interior angle is. We've done that. So this one says, find the interior angle sum for the 18 gon. How many degrees are inside of an 18 gon?
No, wait, oh dang it, wait, I forgot.
So now it's kind of recalling information. If you have a shape with 18 sides,
2008.
how many total degrees are in there? That would be 18 minus 2 times 1/8. How many total degrees is that?
2008, and it's 160.
What did you say the next part was?
160 per angle.
Nope. Why can you not do that?
Oh,
Did I say it was a regular 18 gon?
Um,
No.
so that would just be your answer?
That's it. 2,880 degrees. Because that 18 gon, let's say I made it a pentagon, could look like this.
You can't do it unless it says regular. so
Yeah,
it's
this is
single.
not a regular pentagon. That's a 5-sided figure. This could be like 10 degrees and like 140, 160, whatever. As long as it adds up to 180, it works. But don't assume that they're all equal unless it says it's a regular shape. Alright, now it says find the measure of one interior angle of each regular polygon. Round to the nearest tenth if necessary. So if I give you a regular decagon, the first layer is, how many sides does the decagon have? 10. So I want to know how big is each individual angle for a decagon. How did you compute that? This one?
Yeah.
That would be 10 minus 2 times 180 divided by 10.
Yeah.
So how big is one individual angle? 144 degrees. So I'm assuming that a regular decagon has 1,440 degrees in it. 144 degrees. Is anybody lost or scared or confused right now? What about a 16 gon? How big is each individual angle for a 16?
157 degrees.
So what is that? 157.5?
Yep.
Degrees. It's too easy, right? Too easy.
I feel like I'm gonna do something like really weird right now.
Let me go extra.
Yep.
Okay. So in this regular decagon, each individual interior angle is 144 degrees. So I'm gonna give you a small snippet. How big is this angle out here? That's called an exterior angle.
Wait, is it a regular?
So this is a regular decagon. It has a 144 degree angle here. How big is its exterior angle? 36. How?
Because they have to equal.
It's because the interior angle and the exterior angle must add up to 180. So these two are called supplementary angles. They add up to 180 degrees. Now, how many exterior angles does a decagon have? Well, if it has 10 interior angles, how many exterior angles does it have? So what is 36 times 10? That's
Oh
weird.
my gosh.
That's crazy.
What? That's just one shape. What are you assuming is going to happen?
It's gonna be a bubble.
So if
I just
one
did quadruple.
interior angle for a 16 gon is 157.5, that means that one exterior angle is its supplement. So if there's 16 interior angles, how many exterior angles are there?
16 and
What's-
360 degrees.
Whoa.
I did the quadrilateral one in my head and it's worked out right.
So here's what I'm trying to get after. No matter what shape you have, the sum of the measures of the exterior angles is always 360 degrees. What kind of triangle is that?
That's an
Equilateral.
equilateral triangle.
Because it's equilateral, it's also
Regular.
see where this is going. So if that's an equilateral slash equal angular triangle, each angle is 60 degrees.
And then outside is 120. Actually, outside is like 40-something degrees.
So if you add those three 120 degree measurements up, how many degrees do you get?
360.
Okay. Make sure you know that for
Pretty
your
good.
So and that's what we just talked about with the exterior angle sum. Now, right here it says the sum of the measures of the exterior angles for a polygon is always 360, no matter what. If I give you a 100-gon, how many degrees do its exterior angles add up to? 360. No matter what. If I give you a 1,000,000 gon, how many degrees do the exterior angles add up to? 360.
Is the outside of a triangle 360 degrees?
Seriously?
Yeah, right. Wait, so the degree measurement of a triangle, that's both outside. Wait,
How many degrees are on the inside?
did I say triangle?
Yeah.
I meant to say circle.
Circle. That's a different shape and a different type of geometry. Non-Euclidean geometry. This is Euclidean geometry. So this is what we call polygons. Circles are part of the conic family, so they don't use base, height, length, width. They use radius, circumference, diameters, chords, tangent, secant, all that stuff. Okay. I'm going to give you a gift here. It says, find the measure of the exterior angle, round to the nearest tenth if necessary. So I'm giving you a 30gon. I want to know how big is one exterior angle. So what is the process you're about to embark on? What? 360 divided by 30 equals what? 12 what?
12 degrees.
No.
12,
Where's 12?
12 degrees. Because you're dividing 360 degrees by the 30 exterior angles.
Question mark. Maybe that works, but we don't know what it means. So if you have a 30gon and you're looking for the measure of one exterior angle, the book wants you to work it this way. What is this? 30 minus 2 times 180 divided by 30. 168 degrees. This is the interior angle. The book wants you to use its supplement. So 180 minus 168 equals. So this was correct.
So do we need to do like the bottom one?
This is what the book wants you to learn. This is what I'm teaching you.
Okay.
So I'm teaching you a new formula. 360 divided by n equals the exterior angle. That's what we did right here, right? We did 360 divided by a 30-sided figure. That means that each angle is 12 degrees on the outside. That makes the process substantially faster. So how many degrees is one exterior angle for a heptagon?
That's like 7.
That's the question for you to answer. How many sides does a heptagon have? 7. So 360 divided by 7 should equal the exterior angle. What is it?
That's 1.4286.
$51.4, because what do the directions say?
To the nearest 10.
Round to the nearest 10. So this formula also works the other way, right? Manipulating formulas. If you do 360 divided by the exterior angle, what should it spit out? The number of sides. That's just taking this formula and flipping these two quantities, the denominator and the answer. So if I gave you a figure has an exterior angle that measures 90 degrees, how many sides does that shape have? 4, because 360 divided by 9 is 4. If a figure has a 72 degree exterior angle, how many sides does it have? 5, because 360 divided by 72 is 5.
Do we have to like memorize the exterior angles for like the shapes?
No, because you can calculate the interior angle, can't you?
Oh yeah. But like we wouldn't have to like do the interior angles.
So if you're confused on how many degrees an exterior angle is,
no,
I'll give
like,
you-
like we have to like memorize the regular stuff.
no. And here's why. If a shape has 8 sides, 360 divided by 8 will give you the exterior angle. So you don't have to memorize it, you can compute it. This is a through and through pre-AP test right here. Question. Guys, there is only one layer of this that is geometry specific. Everything else is algebra.
Oh,
Is it a regular polygon?
Does it say that it's a regular polygon? Does not.
it's a pentagon.
It is a pentagon.
If you find all of the amount of angles, the amount of degrees in a pentagon, it's 540. So then you
That's
just-
called the interior angle sum. So the interior angle sum for a pentagon
You just set it equals up.
is 540 degrees. That is the only geometry layer to this entire problem. There is 540 degrees in that pentagon. Then you have to embark on your journey. 5x plus 5 and 4x minus 10 and 4x minus 10 and 4x plus 15 and 4x plus 15 all have a summation of 540 degrees. Man, wait till I give you an octagon.
Oh, it's 8.
So if you do 4, 8, 12, 16, 21 x's. $15 plus 15, 30 minus 10, 30 minus 10,
20.
minus 10,
10.
plus 5.
15.
So all that boils down to this.
21x.
So can you get from here to here? Well, I don't know. Then can you get from here to the answer?
Yes.
Okay, subtract 15 from both sides. Divide both sides by 21.
Oh, I got it. It doesn't say that.
That's not the answer.
That is not the answer. No one cares about that answer. Find the missing angle measures.
You have to plug them in.
Plug them back in.
115, and then that is 130.
Now, I wonder, if you add all this together, do you get 540? Wait,
Yep, you do.
you sure do. That extra little step verifies all your mathematics is correct. Fun stuff, right? Just me? So maybe a little easier here.
That was
It says find x.
1, 2, 3, 4, 5, 6.
What are you counting?
Sides.
Counting sides?
Yeah.
Could you count angles? Does it
Yeah.
matter?
This rate.
That's a total of 720.
So it's 90 plus 4 plus 1.
Okay, we're missing the first layer of geometry.
720.
There is 720 degrees in this shape. I know that because after 10 years I've memorized that. Hexagons are with yeah. Hexagons are 720. Lies. So if you add up all of the angles and subtract that from 720, it should leave you with x. How big is this angle?
90.
So 90 plus 124. We did that already. And your calculator's broken or what?
133.
What is it?
I got 133 degrees.
When you add all these together,
Oh,
Yes.
I got 587.
okay. So if I do 720 minus 537, 133 degrees. Does that answer seem to be correct? Is it an obtuse angle? Okay, let's see what else we can do here. It says the measure of an exterior angle of a regular polygon is given. Find the measure of the interior angle and tell me how many sides it has. So you guys look at this and you get concerned. It seems like a lot of work, doesn't it? So if I give you an exterior angle, how do you find the interior angle?
You could, so you could do like 180 minus 20.
Exactly, the supplement. 180 minus 24 is
156.
So the interior angle is 156. And how many sides does it have?
15.
How do you know that?
360 divided.
Perfect. If you do 360 divided by the exterior angle, it should equal the number of sides. So 360 divided by 24 equals 15. Equals 8. Is that bad? So it's being familiar with the formulas. If I give you a shape that has an exterior angle of 18 degrees, how big is the interior angle? The interior angle measurement is 162. How many sides does that shape have? 20. So that shape is called a 20 gon. 20 gon. This was the last one. No, I got two more. So it says, given the interior angle sum, how many sides does this shape have?
Number 11 is an octagon. 3.
That's an octagon?
Yeah.
But do you know how to solve for it?
I wrote it down.
Okay, what does that calculate? How many degrees are in a shape? The interior angle sum. Well, what is the interior angle sum? 1080. So if I backwards solve that, I can solve for n. Now be careful when you do this. What do you do first? No. PEMDAS backwards because you're solving.
Divide.
6. 180 divided by, or 10,000, 1,080 divided by 180 is 6. So how many sides does that shape have? 8. It's a tough one. Right? And that's going back and saying this is how many sides the shape has. I'll give you one last one. You want to see how this is supposed to work? You want to see how the book teaches this? Is it this one? Oh, it's this one. It says, given the measure of one angle of a regular polygon, find the number of sides that it has. Given the measure of one interior angle,
The 108 is 5.
you know that, right? You memorized it?
Yeah.
So here's how the book tells you to solve it. N minus 2 times 180 divided by n equals the one individual angle. All right, this is one angle inside of a regular polygon. So what do I have to replace the n with? How many sides does this shape have? Exactly.
Why would the book teach you that way?
Because it's just straight up math. Cross multiply. This is the formula that they gave you. Distribute. Subtract 180 from both sides. Divide both sides by negative 72. You got to 5. That's disgusting, isn't it?
Couldn't you just find the exterior angle?
And that's exactly where I was hoping you guys would get to. If the interior angle is 108, how big is the exterior angle? 72. And does this look familiar right here? 360 divided by the exterior angle?
You're doing like all that extra work just for that one part.
For that one point to prove that. So if the interior angle is 35, how big is the exterior angle?
Wait, no, 145.
Yeah, what?
It's 2.48 sides.
2.5
Is it possible for a regular polygon to have one angle that's 35 degrees?
It's not a
No, because what's the smallest angle you can have inside of a regular polygon?
60.
60. That
Not
wouldn't be
possible. False. Who did that? Was it wait, guys?
There's something supposed to be 135, and I deleted the one on accident. So here's a graded assignment.
Is it like that time that you give that person like 1,000 on their test?
Oh yeah, probably. I will give you guys the challenge if you're interested. For extra credit points, if you create